Welcome to the Nature Journal workshop. Today, I am joined by our two hosts and a special guest. Add spotlight here. I'm going to add spotlight here. Let's first, we're going to go to our two co-hosts, Melinda Nakagawa and Evea Moore. We're going to give us a little bit of an update on cool things happening in the nature journaling community. If you want to do if you want more of this, it's the place to go. There's some really fun things coming up. Today, I'm going to start by bringing in one of our youth sort of thought leaders. So Ray Bonto, I'm going to make you a co-host. Right. I would like to, the reason which we're having astronomy workshop today is because of the inspiration of this young man here, Ray Bonto. It's good to have you with us. So you woke up one morning, you looked out your window, you saw a bright star out there, and you looked at the stars and the patterns of the constellations, and then went back later and then added that view from your window into the into your nature journal as sort of documentation of the planets that you're seeing outside your window. Is that right?
Yeah. Yeah. So yeah. One day and also one night, I was having dinner and I saw a very bright star. And I took out my spotting scope, just then it disappeared. When I saw it again, I quickly took out my spotting scope. I got out my spotting scope and I saw stripes. I thought it was Jupiter, but it turned out to be a plane. Out of some evidence that I had thought of. Like, after a while, it started accelerating, and then when I look at Jupiter, I can't see any stripes.
Also what you're doing is when you find bright objects in the sky, you try to get those through just your bird watching spotting scope and draw and describe those in your nature journal.
The method I use is I have a 15 to 45 times spotting scope by zoom, and I start at the 15, find the object, and zoom in. I recommend the spotting scopes or zoom in telescopes because it's much easier to like zoom in, because the object will move around as you're zooming in, and you're not quite sure whether the object is quite centered in the eyepiece. If you have the regular telescope and you're going to change the eyepiece.
So you're telling us that when you do find bright objects in the sky, you regularly put those in your spotting scope, and a system that you've come up with that works really well to do that is because you have an eyepiece that will zoom, sometimes get you closer to the object or further away. You start with it in the setting where you're the furthest away from it, so you see the largest field of view in the sky, and that helps you then find that planet, and then you zoom in on it.
Yeah.
Excellent. Thank you so much for telling us about some of your astronomy adventures. We're going to let you get back to the concert there, but I just wanted to thank you so much for sharing your past astronomy adventures with us here and in past workshops that really inspired us to kind of get an astronomy focused workshop to today. And also good for everybody to notice that just your bird watching spotting scope is a fantastic tool for astronomical investigations.
Yes, and one last thing. The best time for bird stargazing is before the sun has risen, like way after midnight, but before the sun has risen, because at that time everyone's asleep, so there'll not be as much light pollution. You're muted.
Yeah, that's a really good point. That kind of that morning hour, if you can get yourself up early, you'll find darker skies, even if you are in an urban area. Then in the evening, most people have their lights on. They've just finished their dinner and they're doing whatever it is they do. Early in the morning, everybody's asleep, all their lights are off, and that's the time we have much less light pollution. When you do find yourself out at a place with a good night sky, this is a fantastic time to anticipate that and to prepare yourself to go gonzo with nature journaling in your with the night sky. So we're going to look at some strategies that folks can use to do that now. Again, Ray Bonto, thank you so much for spending part of the start of this workshop with us. I know you're going to have to leave early at the end and we can't connect with you at the end of today's class. But thank you for being willing to share some of your astronomy adventures with us here at the start of this workshop.
Yeah, thank you for inviting me.
Great. Really good to see you.
You too. Thank you.
All right. We're going to teach everybody a bunch of strategies that you can use to nature journal like Ray Bonto. So first of all, the tools that you use. In terms of tools, the most important is your nature journal. So bring your nature journal with you. We can augment our nature journal with some sort of special things that will make it easier for us to record what we see. And we'll be going over some of those strategies. You can use binoculars for looking at objects in the sky, but I personally find, because my hands wiggle so much, that it makes it hard to be looking at a distant star that then seems to be doing a little dance. That's why a scope on a tripod makes such a difference. And for me, I don't have a special astronomy tripod. I mean, an astronomy telescope. I use, just like Ray Bonto does, I use my birding scope for looking at objects in the sky. And it allows me to do some really wonderful stuff. So, but again, the tripod is very, very, very helpful. Let's take a look at a few strategies that we can use in order to draw what we see. The first and the easiest is just the negative view of the sky. So let me jump over to this. Hello there, Pepper. There we go. So if you have a regular nature journal and your nature journal has white paper, what you can do is just think of it as the negative of what you've seen. So if you see a star up in the sky, I put a black dot on my white paper, right? And this works great. And then what you can do is you can by sort of looking at the angles between things, you can pick out objects in the sky. The bigger the dot that you make, that means the brighter the star. So make small dots for dim ones, big dots for others. And in my brain, I cannot keep track of too many orders of magnitude, too many different brightnesses. So what you might do is just have one dot that means most stars, and then a big dot that just means really, really bright stars. And you could then also use just tiny dots for 1/3, but for most of us, just big dots and regular star spots are going to be as much as we're going to be able to kind of manage out there. If I am sketching a pattern that I see in the sky, start with one dot, and then instead of putting in the next star, get out there and hold your hand up. Actually, I'm going to turn the camera back on my face for it. What I will do is I'm looking through my scope, or I'm looking at the sky. I will get my hand up in the sky, and I'll say, and I'll air draw the little line between these two stars. And that gets me thinking of this one is up at this angle. And then you want to think of, so which direction does it go, so you can kinesthetically get the direction of it. And then what you want to do is figure out how far to put it out. And there are several strategies that you can use to do this. One very kind of useful one is to use the degrees of arc system. And in the back of my journal, I have a little picture of hands doing, it looks like there's some sort of secret code. What those little hand drawings are doing is showing you sort of the degree of arc system, the way it works for most people. And what that is if you take your arm and you put it out at arm's distance, and then you hold up either a finger or 3 fingers, or your fist, or rock on, Garth, or shaka, right? These different symbols, so scouts, shaka, rock concert, and pinkies up, and solidarity, these hand signals have different widths. And if your arm is at full arm's length, then the width of your hand is 10 degrees across the sky. The Boy Scout sign is 5 degrees. The rock on is 15 degrees, and this is 25. So if an object is above the horizon, I will go like this, like that. Oh, it is 50 degrees above the horizon. Another way of doing that is go like this, 2, 3, 4, 5. Oh, it's 50 degrees above the horizon. If an object is just a little bit to the right of the moon, I can say like, okay, arm at arm's length. And you're thinking like, but everybody has different size hands and arms. Yeah, but we also have different size arms. So it kind of averages out that for most people, when you kind of average out the size of our hands, the length of our arms, this system does a very useful job of helping us kind of approximate distances in the distant sky. So again, in the distant sky, you can't put up a ruler because that ruler is going to change depending on how close or far it is from you. But if you imagine yourself in a 360 degree sort of ticked off thing, 10 degrees, 10 degrees, 10 degrees. So what I can do then is I can say, all right, that's about 5 degrees away from that. If you are then transferring that to a piece of paper, you can put that same 5 degrees down on your piece of paper and put a little mark it. Hold on a second. We're going to bounce back here. All right. So if there is something that was 5 degrees off to the side of that, I could do that and then say, you know, there's my other star. Or what I could do is if I've drawn that shorter, I can say that this, for scale, this is 5 degrees. Or I could just off on the side of my page, just have a little I bar and say that this, for scale, this is 5 degrees in this celestial diagram that I just did. What this does is allow you to put in scale. Or if I've got several different objects that are lined up, I can count how many degrees here. This was 15 degrees. This between this one and this next one, it was 25 degrees. So that way I'm putting in my measurements, even if I've put these dots on my journal page at slightly different distances that are wrong. If I have written in those sorts of marks, I'm good to go. You can have, there's a bunch of other things you can do though, that allow you to kind of take something like this, just these black dots on white paper, and take it to the next level. One thing you can do is you could use a piece of gray paper. So gray paper is great because gel pens show up on it. Ooh, it's a star. Right? And there's something just very, very appealing about having your stars be white. That's really fun. Now, the same is true for a piece of, well, on here it looks gray because there's light from my house reflecting on it. I'm going to turn that off. It looks a little bit darker now. This is a piece of black construction paper. Oh, look at that. Oh. Hey, oh, I've got magic hands. Watch this. I will make my page turn dark. If you touch your paper, you can make it turn dark. Isn't that neat? I never knew I had that power. Look at that. These little guys show up really well on that. The disadvantage is that if you right next to that, that's a star, it can be harder to see your writing on the black paper, and the writing shows up much better on gray paper. But you know, this does have this sort of neat feeling of night sky. So there I was using a gel pen. This is a jelly roll pen. There's 2 types of gel pens that I like. Jelly rolls are good. The other kind, it works very well. Actually, I think they work a little bit better than Jelly Roll. It's just that I happen to have Jelly Roll accessible to me here. Just a second. Where did I put my angles with the pencils? Oh, here it is. This is the Uniball Signo pen. It's another gel pen. I prefer these to the Jelly Rolls. They are a little bit more opaque. So should you get yourself a Signo, you will be happily Signoed. But they work great on toned paper of any color or stripe. So with toned paper, I can handle that several ways. I can, let's back up, whop, whop. If I have a journal that is, say, this size, what I can do is I can cut out a little piece of this paper and tape it into my journal. Or if I've got this out there in the field with me, I can work on this in the field and then come back home, tape these and kind of glue them in, but you can glue them in advance. Another thing that you can do in advance is if I know that shortly I'm going to be going down to the desert and playing and doing some astronomy observation. In preparation for that, I've gone to the back of my journal and I have put in a couple little night skies, just some blotches of tone. And then what I will do is, if it's something that is sort of deep in the sort of the sky above me, I will just sort of draw stars in on here. And if it's down near the horizon, I can draw a little black horizon in there. You draw a little black horizon in, it really starts to feel like night. So that this will take those gel pen marks very, very well. Another thing that you can do is after you've got marks like this on white paper, you can come along and paint over that and then re-darken your marks with your gel pen. So that ends up looking a little bit like this. So here are some astronomical observations that I was making. And what I did is I started just with pen on paper. So you notice there's between this object and this object, there's 15 degrees. Between this object and this object, there's 50 degrees. I just, in the field, drew these out, so it was all a line drawing on my page. Also, look at how nice the little horizon line is when you throw that into your night sky thing. When you can, doesn't that add just a little horizon down there? Just go solid black and put that in. You can even use a Sharpie if you wanted to. And that does a lot to sort of to put you back there. So that's sort of put you in place. So I'm looking at these bright objects in the sky. What I first noticed is there's this really bright object right next to the moon. And I thought, whoa, check out Jupiter right down there next to the moon. That's really cool. I got to get my scope. So I ran inside the house and I got that object into my scope. And when I did, it looked like this. So this is an enlargement of this. And isn't that interesting? It was a half of a circle. When you see that in the night sky, what's really fun is that you have just narrowed down this planet to two possibilities. There's only two things that you could see that have that shape. Well, the moon, of course, can have that shape, but you only see crescents and half and gibbous. You see phases on the, so if this is you, here you are on the Earth, and the sun is over here. So the sun is sending light out like this. If you look towards the sun, let's say you are in on the night side of this. So if you are looking out into space from the night side here in this direction, so that'd be something close to the horizon, but you're still, it's night where you are. And again, you'll only be able to see these when you're close here, where you can kind of look out this direction. You can actually see planets that have orbits that are between the sun and the Earth. And so when you're looking out here and you're seeing planets that are out here, oops, let me keep this on the screen. You can see Mercury and Venus as they will have phases just like you see on the moon. You can have a full Mercury, you can have a half Mercury, you can have a crescent Mercury.
and so too with Venus. But for the rest of the planets that are out here, from our position on Earth, we are always looking at the face of them that is pointing towards the sun, because it's also, that's the face that is pointing in towards the orbit of Earth. They are so far out that you always see these outer planets as the full face of it. So you never see these ones out here as a half. So this was really exciting to me. I knew that I had Mercury or Venus. And because it was a little bit later past sunset, I was thinking this is probably going to be Venus. Mercury is very, very, usually see it really close to the sun. So you'll see that just right when the sun sets. A little bit after that, the Venus will set. So this already had a dark night sky and it was half, so I'm thinking Venus. So I've drawn an enlargement of Venus. And then I look out along this line of going from Moon through Venus, and there's another object out there. I get that in my scope view, and I get this little shape. That's actually what I'm seeing through my bird watching spotting scope. And so I just want to show you a Saturn drawing trick. So when you are sketching Saturn, what I usually do is I just sort of start with a round ball. So this is outside of the orbit of Earth. But then look at what is the negative shape of these two little arms here? What is the negative shape of that and the negative shape of that? So get those negative shapes and then wrap the rings around that. So Saturn is fun because sometimes from our vantage point, the rings are in line with us. Sometimes from our vantage point, we see them from this view. Sometimes from our vantage point, there's a very narrow little ellipse, right? So you will see, if this is my Saturn, I'll have a little bit of dark here. I'll have a little bit of dark here. But getting the shape of those negative shapes is really going to help you with your Saturn sketching. And then I look a little bit further on beyond that, and there is this incredible formation in the sky. There's a round object, and there's a line of dots in a row next to it. So what is neat there is that you're looking at the planet Jupiter and the moons that are on Jupiter. And some nights, if Jupiter is high in the sky, you won't see this when it is, you won't see this when Jupiter is low in the sky. You won't see this when Jupiter is low in the sky, but when Jupiter is really high in the sky, you can sometimes see the gas bands across Jupiter. The other night I could. So what you're then doing is you're making a drawing of Jupiter, and you can show the relative distances out from that planet that those little moons are. If you draw Jupiter this way, where so fun things that you can do with Jupiter is if you want to do Jupiter observations over a series of nights, give yourself a week of Jupiter watching. And what you do is you make a little chart like this. I'm going to have a line going down like this, and these are going to be all my Jupiters. So Jupiter is always on the line. And then 90 degrees from that, draw in the locations of the moons that you see on one night. Next night, draw in the locations of the moons that you see on that night. right? And then over a series of nights, you're going to get different positions every night on your moons. And what Galileo did is made drawings like that, and then realized that you could connect some of those with, as a moon is orbiting, they are going to be making a little sine wave down this. So where a moon, the same moon will appear, you can actually connect those. You can figure out which moons are further out. You can figure out which moons are further in. If you create a series of Jupiter drawings over a bunch of nights, you can then sit down with those and try to figure out what are the ones that have the widest orbits, what are the ones that are closer to that. So again, Jupiter's all lined up, 90 degrees, put the plane of the moons in there, and then map those over a series of nights. You can really have a lot of fun with Jupiter. It's a great planet. Just want to point out a few other things kind of going on this page. So I've got my measurements in. I've got close-ups of what I'm seeing. And I'm trying to draw these at the angles that I'm actually seeing them in space. So what I thought was interesting was that Venus was at an angle that lined up with the the crescent of the moon. Saturn and Jupiter, the plane of Jupiter's moons, was different than the angle that I saw the rings on Saturn. So that means that they're slightly, they're not all in perfect sort of the plane of Jupiter's moons. Saturn is at a slightly different angle. I didn't know that, but I can figure that out by looking at my own observations. So I'm helping myself sort of figure out what is the geometry of this sky. I thought it was also interesting that if I drew a straight line between Venus and Saturn and continued that on, Jupiter wasn't on that perfectly straight line. Jupiter was a little bit off of that. So all the planets weren't on a perfectly straight line, kind of going out. But isn't that fun? You can have a ton of fun playing with these sorts of things. But wait, there's more, because we can also geek out with the moon. Let's take a look at things that you can do with the moon. So this is, if anybody joined us for Moon Night, this was a kind of a fun night. Some time ago, we had International Moon Night, and we're going to have another one. We actually get to decide where they are because it's something that we just made up. But we're going to have another sort of moon observation event. Cool things to note are, what is the angle of the moon relative to the horizon? So if you think of the 360-degree clock, this is up tilted at a 30-degree angle here. And so what is, or this was sort of rocked up from the horizontal plane up 30 to 40 degrees. I calculate that just by holding my my little goniometer to the sky. This is the goniometer. So it's a tool for measuring people's joint movement, and physiotherapists use them. You also can find these, I now sell these on my website, but it's a long ruler, but it also helps us very precisely measure angles. So I was holding this up to the edge of the moon, trying to figure out exactly what angle this is at. And that same thing of kind of looking at, so that was at one particular time. This is at the moon's position at moonrise. But I can also do that through time in one night. So this little bit of business here, this is looking at the angle of the moon at, this was at 5:30, and then at 8 o'clock, the moon had rocked over at an angle like that. And then later on at 9 o'clock, it was an angle like that, at 10 o'clock, at 11 o'clock. So between 5:30 and 11 o'clock, I can see how much my moon rotates. What I'm looking for is this, what you can do is try to look at this over the course of a night. The moon, let's back out. The moon is going to change its angle in the sky as it goes through the sky, and you can track that. So things that I'm going to be looking forward to doing, and I may be out there this evening doing this, is I want to calculate just how much this rotates per hour. And I can learn that from my own direct observations. I'm sure there's some place in a book that I can look that up, but I'm going to try to do it. My guess is that it's going to be rotating at about 15 degrees per hour, but I want to find that out. More observations will allow me to be a little bit more precise than this little thing. So if I start earlier and end later, that's going to be the best case scenario. So you can see, you can look at a lot of really cool stuff bopping around in the sky there and play with that. I want to show you one other idea that was an idea that Ivea had of a really cool way of collecting astronomy notes. Collect astronomy notes. And her idea was, all right, start with a piece of toned paper. But what she did is she turned her piece of paper into a zine. She made a zine out of this piece of paper. And so what I'm going to do is I'm going to show you how to fold your own little zine. And so I'm going to ask everybody to go get yourself a piece of, get yourself a piece of paper. Get yourself a piece of, it can just be a piece of scrap paper out of the recycling, right? And we're going to fold these pieces of paper to make your own zine. And you're going to see why you want to do this. Give everybody a moment to do that. Right? You're going to want to fold one too, because if you watch me do it, it's not going to stick. If you fold yours along with me, it's going to stick in your head. And then you can also reverse engineer it. You can unfold it to figure out how you got back there. So first thing, what you're going to do is we're going to take your corner of your piece of paper. You're going to fold it up like this. Line up this corner, and then fold along the side. That's called a hot dog fold. So what I've done is taken my piece of paper, I folded it in half, lined up those two corners really nicely. That's a hot dog fold. So I've made myself a hot dog fold. And I can then kind of come along with my pen here. I'm going to burnish that end down. Now I'm going to make a hamburger fold. So instead of folding it the long way, which is hot dog, I'm going to fold it the short way. There you go. And I am going to burnish that down a little bit more. And now I'm going to fold it over one more time. To make one more hamburger fold. Hot dog would be up that way. One more hamburger fold. Now you're looking at this and you're going like, yeah, this is not so useful because yeah, you've got this piece of paper, you can unfold it like this, but what's so great about that? Well, I'm glad you asked, because I want everybody to unfold your piece of paper and then flip it down hamburger style. So you folded this, folded this, folded this. You're going to open it up. And instead of putting it in hot dog, let's everybody flip it to hamburger. And now, I am going to, where did I put my pair of scissors? Aha, here's my pair of scissors. I'm going to take a pair of scissors, and you see how this end is right here in the middle? This thing is right here in the middle. So I'm folding it over here from that side that's all connected, not the side that's open, but the side that's connected. I'm going to cut this piece of paper halfway through. So I'm going to stop cutting when I get to that crease in the middle there. So I'm going to cut up here. Boom. See that? So I just went to the end that was solid, cut a little crease in there. And now I'm going to open it up again. I'm going to fold it hot dog. And this time, I'm going to set it up on its edge. You see this little space in there? I want to make that bigger. So I'm going to take these two sides and I push them together like this. See what I did? I had this piece of paper, take these two sides, bring them together, and then I'm going to fold all these ones around the same way. And this, flatten it one more time. Really give this a good flattening. Flatten over here, flatten over here. And now look at this. Now I have, out of that big piece of paper, I've got, oh, here's page number 1. Here's page number 2. Here's page number 3. And here's my back cover. I've made this little book of black paper for recording my astronomy observations. So I can put one little observation here, one observation here. You can write on it with your gel pen. And it's a great little astronomy book with dark tone paper. You could then take this and glue it inside your nature journal. You could get in there and just sort of glue in that back page, and then you'd have this little notebook in there of all your cool little observations. How much fun would that be? So that was a crazy good idea by our own dear Ivea Moore. So mad props for thinking of the black paper zine. Want to show you one last thing that you might want to record. So we talked about
we talked about,
you can through the night. Oh, well, the other thing that works great on this sort of, the thing that works great on this kind of paper is drawing with white colored pencils. So here's a little white colored pencil. Let's say I am, drawing in the moon. You can, so you can draw with this. You can also make great Milky Ways with a white colored pencil, right? You can, if you've got little gel pen stars, you can give yourself a little Milky Way across part of that. So these are, where'd my journal go? There's my, no, that's not the one I want. So just sort of thinking of things that you can do that are going to be fun. So here is one night making observations of different objects and what is their relationship to each other. This is one night at different times recording the position of something. Another thing you can do is pick something like the moon or planets and record where they are in your sky at different on different nights. So you're going to see that as the night goes on, stars change their positions, so you can record that. But each night at the same time, that one star is going to be in a slightly different position. The stars will all keep their positions relative to each other, but where they are relative to your horizon is going to change. That's something that you can record in your journal. And then what makes the planet so much fun is that across this background of stars, your planets are going to move across that background at different rates. And so the stars are all keeping their positions. The planets will be in slightly different positions night to night to night to night to night. And the further they are away from the Earth, the slower they move across that background of stars. But you can, over a series of weeks, of months, record those positions. So I want to bounce over to I'm going to share a screen with you. Share, do. All right, so this is a map of the night sky. This curved line across it is what's called the ecliptic, and that is the path that the sun takes and the moon takes and the planets take across our sky. And so if you see a bright object and it is on the ecliptic, what's really fun about that is that you can that it's probably going to be one of those planets. If you map it night to night to night over a series of months and it changes its position, you can figure out, yep, that's one of my planets. So you can print out a star chart like this and put your planets on it, all color coded for this month, come back a few weeks later or a month later and see where those are. And they're going to be moving relative to this background of stars. So printing out a little star chart and charting where the planets are on this is really, really, really fun. There's one last thing that gets
if you want to go down the rabbit hole really, really deep, what you're going to find is that planets are moving from west to east across this line. So the planets will be doing this over time. Okay, but if you are mapping them carefully, what you will find is that sometimes for a part of the month or for a series of months, a planet will change its direction along this line. So what you'll see if you're mapping a planet is that it will be moving along, doopty-doopty-doopty, right? And you think it's going to continue on doing this, and then it slows down. It stops in the sky relative to all these other stars. It goes back the reverse direction, slows down again, and then continues on its merry way. That's crazy. And depending on your position, depending on the planet, you will sometimes see them make a loop in the sky. Look at that. So coming along, right? This one just made a little loop-de-loo in the sky. So this is the astronomer who took this picture, got up night after night over a series of a month or two, and turned had a telescope that you could automatically turn to the same part of the sky. And then each night, or each observation session, put in another one of these little dots. That's crazy, isn't it? It switches direction. So when the ancients first saw this, they thought to themselves, well, okay, I mean, here's these, so that something wild is going on. These planets that are moving around, those were the gods. The stars were sort of patterns making heroes, but the planets were the gods. And so if they're making this loop-de-loop, they had a model of the universe with the Earth in the center, and then the planet is going around it in everything. The sun and the planets were going around it in a circle, but that didn't explain these little loop-de-loop reverses. So they came up with this wonderful kind of explanation for this, and you can kind of geek out with the geometry of this. Look at this explanation. So their explanation was that Earth is in the center, everything is wrapping around it, but the planets aren't going around in a circle. What they're doing is they are going around in a circle on a circle, so that sometimes they're going to be going back the opposite direction as you're looking at them go around. And so the planet would then be going around this as it is. And so if you are going around when you are, that would explain that apparent loop-de-loop. Isn't that crazy? But what's going on here is even more elegant than that. I'm way over time, but this is just so beautiful. I needed to share this geometry with you. Here, my sun, let's see, my Earth is here, all right? Earth is here, here's my sun, and Earth, I'm going to make Earth on an orbit here. We're looking out at another planet on an orbit out here. The stars are so far away that the stars appear to be on just fixed in the sky as if it was a flat plane back there, right?
So consider the stars as just a solid wall back here. Now, if my Earth is over here, so I'm going to put several Earths in. And let's put in several Jupiters. This is time 1, time 1, time 2, time 2. Oh no, and actually, let me, no. What do I want to do? I want to have them not going at the same speed. I want to have, I'm going to use a different piece of paper. Sorry, this is so elegant and weird that I'm messing up my drawing of it. Sorry about that, folks. Here's Earth. Here's Earth's orbit. We're going to have time 1. Here's time 2, time 3, time 4, time 5. I'm going to have time 6 over here. Here is the orbit of my other planet. Now, because this other planet is further away from the sun, it is not going to make its orbit as fast. So I'm going to have time 1, time 2, time 3, time 4, time 5, time 6. So at time 1, if you're looking up at, here's that, imagine that wall behind that all the stars are painted on. If I'm looking up at this planet, I see it against these stars here. At time 2, right, I am seeing it against these stars here. At time 3, I am seeing it against these stars here. At time 4, I'm seeing it against stars here. I've got my lines too close together. So second attempt to make this drawing just failed. So what I'm going to do is I'm going to cheat and I'm going to use a, I think I may have, stop share. Hold on, one last thing. This is this sort of backwards motion of these stars is called retrograde motion. And I think I pulled out the little diagram I want to make, and I failed to make. No, I didn't. Maybe what I'll do is I will try to make this one last time. Sorry that this part of our demonstration has sort of turned into sort of more delay and confusion. Let's try this one more time. I am going to have orbit of my Earth with my Earths here. All right, so there's my Earth going around the sun. And out here in this other ring is going to be the orbit of some other planet. And I'm going to have it about 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4. Actually, no, I'm going to put this in closer so I'm going to have more room to project. That's where I think I'm going wrong. 1, 2, 3, 4, 5, 6, 7, 8, 9. All right. And then about out here is my wall of stars. So if I am looking at this planet from time 1, I'm going to see it projected here. Time 2, I'm seeing it projected here. Time 3, look at this. I'm seeing it projected out here behind where it was before. And then it's going to start to, okay, sorry, yeah, out here. So I'm seeing this one projected out behind where it was before. And then it is going to be, so first I had it moving this way, and then I had it moving this way. And then it's going to start, so at the start, I had it from here, moving this way. And then when I got in here, that flipped my direction back this way. And then once I get back over here again, I am going back in this direction. I still want to come up with a more satisfying way of diagramming this, but what it is because our planet passes the other planet where it is in its orbit, and we're then looking back on it, for a little while, you're going to see this reverse in the stars. And if you map the positions of these over time, you are going to have a lot of fun. So I'm going to now put up a little chart of when these regression events are happening for the coming year. So check this out. So Mercury is hard to do because it's so close to the sun. They are, I don't recommend trying to track this one unless you've got, you know, a telescope and you're really kind of good at things. But Jupiter, Venus, and Saturn, these are much easier to see, especially Jupiter and Saturn. Really kind of easily observed planets in the sky. So between July and November, Jupiter, so if you start, you get yourself a star chart and start tracking the position of Jupiter, somewhere in before July, you'll get Jupiter moving along and you'll find out sort of what its sort of direction and motion is. Then in here, it's going to come into retrograde, and it's going to go backwards and then slow down again and then start going forwards, and that will be done. It'll be done going backwards, and it'll start going forwards again in November. Saturn does that between June and October. And so that's a really fun thing to look for if you're looking for kind of more naked eye things to track. And but again, the best way to do this is to draw yourself or to print out some little star charts of the part of the sky that the planet is in, and then to track that over those months. That is retrograde, and apologies for a very confusing retrograde diagram. Let me bounce back to this. And so what I want to encourage people to do is to let's start playing with the night sky. You can play. The nice thing about tracking retrograde is you don't have to be out there every night. Like if you go out every 3 weeks, you'll be able to track the retrograde. If you get the position of Jupiter in the sky relative to the constellations, you know, you can go out, you can miss weeks and then get out there and do that. And it kind of puts us in touch with these really kind of neat things going on with the orbits of these other of the planets.
with all these other crazy things going on around us. And I hope you have some fun with that. So that is some kind of low power astronomy that you can do to have a lot of fun getting your place in the universe. Oh, and anytime it's during the day and you see the moon, you can drop that into the corner of your nature journal sketchbook. And it's just sort of remind you that we're here on this little rock. We got a moon going around us. That's really fun. I hope there's some useful strategies in here, and mad props to the mad botanist for her suggestion of the little zine. I hope you had a fun time making your own. And certainly if you've got kids, everybody's going to want one of their own. You can do it as a craft project. All right, let's bounce over to kind of a community discussion here. We are going to, if you've got any comments, thoughts, questions, or ideas about sketching astronomy, why don't we start with those, and then we'll go on to a general journal share. We're going to make it possible for you to unmute yourselves. Right, you can now unmute yourself. And I am going to start with Eve, the mad botanist. Hey there.
Hey there. This was fun. You gave me lots of really fun ideas to try out now, so I'm extremely excited.
Good.
So something that I've been wondering for months and months that Rebonta reminded me about is how to measure light pollution and sky brightness and such. And so there'd been a conversation some of us have been having before about sort of creating like this guide, I guess, for ourselves of indicator stars so that we could sort of see and I think we talked about this before. So, how many of the 8 stars of the Big Dipper can you see tonight? And so that was an idea. And then there's been some other ones. But I was also thinking on the nights that it's overcast and you have to draw those weird clouds, then is there another way to tell? And just found something really interesting I know nothing about called the Bortle scale. And it almost sounds like it's the Beaufort wind scale of the night sky, except instead of wind, it's about light and light pollution. So that might be something interesting to check out.
Bortle scale, that's cool.
And so if anybody has heard of it or tried it, I'd be very intrigued to find out more. Another thing is that if you're like Rebonto or a bunch of us who live in the cities and you get light pollution and maybe don't know a lot of constellations, then whenever you go out to the desert, you look up or anywhere and you go like, oh my God, all of the stars, how do I figure that out? So something else I like to do, and if any of you have notebooks that are in black, I recommend it. Some of you might have already seen some of these, is to draw your constellations on the front of your notebooks so that you can learn how they go. So this one is Hercules. And with this one, to figure that one, because for a while there I was a little bit more of a perfectionist. So what I would do is I would get out whatever sky book I wanted. I would take some tracing paper. I would trace the constellation, and then I'd have some fun. You can barely see it. I'd have some fun with my goniometer to try to enhance it by doing a scale up version of it, which is really challenging. But kind of fun to try it out. So I recommend that. You can see like tiny leg in here, bigger leg right there. So yeah, that's kind of fun. I recommend it. And then I swear I had something else to say, but now I can't remember what it was. But but I just was curious to know if anybody else has ideas about ways to measure the night sky with in terms of light and such. So
Bortle scale, you said?
Bortle scale. I'll put my link to it.
Yeah, it's weird. Light pollution, it interferes with our ability to see the stars. It's also a major problem for migrating birds.
Oh yeah.
Migrating birds get really thrown off by all the bright lights from our big cities, and it deflects their migrations, and then they fly into the cities, and then they fly into windows.
Sometimes it can be fun to put 2 constellations so you can see them in relationship to each other. So does anybody recognize this one here?
Oh, Cassiopeia.
Yep, Queen
Cassiopeia.
Cassiopeia. No, but you were right, on her throne. And then does anybody know this one? The one that looks a little bit like a house to some people.
Cephas?
Yeah, King Cephas. So you have those 2 together. which is kind of fun sometimes to draw them together, because then you start to learn the constellations in proximity to each other, so that when you look up, you may not be able to see King Cephas that night, but you can say, oh, he's going to be sort of over there. Or maybe if she's like up here, then you'll go, oh, okay, that a ways, can kind of help. And then you can make a pun later on when you make your book about monarch butterflies or whatever. Does anybody else ever try to use, my plan is to someday use this that we used for equinoxes to sort of do the night sky. So I'd just be curious to know if anybody else has ever tried that before. And that is all.
Fun. That is really fun.
It is now a time that we can share other stuff going on really fast, or in our nature journal. Okay. Thank you. And then I'll try to be fast. I wanted to give a shout out to Stephanie Dole. If anybody lives in the Bay Area and has heard of the Beetle Lady, she's totally somebody to check out. She recently had her pop-up museum's debut at the Curiosity. Myself and some other nature journalers went, so you might be seeing some of their pages. So she calls it her pop-up bug museum. I couldn't draw the sky very well, but this is one of my favorite cloud patterns. I want to call it like either the mackerel sky or something like that. I'm gonna practice this a bunch because it's a really pretty pattern. Lots of good friends that day, her insecta thing. And so she had some really cool stuff on defense, and I was trying to quickly sketch note what that looks like. Insect defense is like with the startle color, where they flash their predators, or sometimes they have a thorny surprise, like this one has a thorn on the bottom, so that if a bird tries to eat it, the bird learns not to eat that one anymore. Or then I guess this one not only has big old pinchers, but then it also has like a bunch of, almost looks like a dog collar that you'd wear with all of the spikes around the neck. So another thing about not to do and hiding. So that's kind of fun. And then my friend Akshay was teaching me about the beetles and about how you have your head, your thorax, and your abdomen. And one thing I'd learned a while ago was that thoraxes have 3 parts, pro, meso, meta, and that with each part, there is a pair of legs. And then if you're looking for the wings, those will appear, according to my friend Mark, on the meso and meta, on the last 2. So Akshay was teaching me a bit more about the shape of the thorax on the beetles, which was really fun. And then about how the outer shell is called the elytra, but then the flying wings are underneath. So it's like 2 different kinds of wings, and about the way that there's something that goes kind of over the beetle's eye and separates it in halves, so that half of the beetle's eye looks up while the other half looks down. And it was just like so much bug geeking out. And then Jasmine, my friend who's here, she was looking at these lovely butterflies, and so we were drawing them. But then I had the saddest realization. I started doing your kite method, Jack, where you draw a kite to make the butterfly. And then I realized it wasn't going to work because these were taxidermied. And so I was like, oh, because instead of the butterfly's 4 wings being like this, instead, when they're killed, then they're put like this. So do that. So I was like, oh, then the kite method is not going to work. But then, we learned about some indirect flight muscles, super duper cool, about the way that it's not the wings flapping, it's the muscles that are making the wings go up and down. And then Mark Simmons was talking about this in his process, so that was kind of fun too. And then insect orders, where they all stand. I want to know why the beetles are so successful. And then lastly, some questions about what's in a leg. If the leg length can sort of be an indicator about what different functions there are. So we wrote all of the different functions down that we could brainstorm. So that way, for example, with the spiders, you have your front 2 legs that I'm told are to catch things more. So then they go up and over a little bit more. So instead of going like more towards the back where they're like, like this, then they go like that. Mm-hmm. So I'd be curious to know if there's more things you can study about why legs are the way that they are. And then I wanted to quickly share Akshay's boxy critter class with Melinda was just amazing, because what he'll do is he'll make things into blocks so that they're less complicated, so that he can quickly draw the patterns that he sees. Butterfly. Even though it doesn't have the curves and everything else like that, you can still say it reads as a monarch because of the way that you capture the patterns. And last but not least, just had a lot of fun with David Lucas and Marley with their landscapes, which you might be able to see right now with the Nature Journal's cover page. So that's all just major props to all of the amazing educators in our community. And I hope y'all have had a similar fun week. Thanks for listening.
Oh, that's really fun. What your journal has been so active. That's great. Thank you. And thank you for your astronomy ideas and that sort of tour of, there's just so much wonderful inspiration happening in, you've got all sorts of ideas pulled from some that you've innovated and then pulling ideas from other people. That's really exciting. Thank you. Let's jump over to Joni and see what's any thoughts about astronomy or what's happening in your journal.
Some thoughts about astronomy. And we discussed this before in the other class, but another type of mapping we could do, of course, is the circumpolar constellations around the North Star. Through the night, you could map that also. And then I'm sure people are aware of this, but especially fun with kids, although it's fun as an adult too, is to take a sheet of paper, draw out the constellations, and then using the sharp point of a compass, push through to create a hole. And then you can get into a room, make it dark, and then shine a flashlight underneath it and project those constellations onto the ceiling or wall. So just another thought.
Joni, those are great ideas. Yeah, your idea about the Big Dipper is a really fun one to do. And that's also a great way to help people be able to, because it is so close to the pole star, if you are in North America, a really fun activity to do is when you go to bed. So first, let's find the Big Dipper and its relationship to the North Star is very, very useful. So there's a constellation in the sky, we call it Big Dipper, and it looks like a little water cup with a handle, double star right in there, Miser and Alcor. And if you go to these two stars on that cup and you draw a line through them, you get to the North Star. And what's neat is that this spins around as the night goes on. If you imagine this sort of all rotating on the North Star, this all the constellations and the including the Big Dipper, they all spin around it. So if when you go to bed, these two stars were here, right? You're going to see those going around in a counterclockwise direction as the night goes on. So eventually these two stars, they're going to be here pointing towards this. So you can use that, and every night, every 24 hours, it does a full circle. So that means if it goes all the way around in 24, it goes halfway around that in 12, and it's going to go a quarter of that in 6 hours. So you can use these two pointer stars that point towards the Big Dipper then as a nighttime clock. Look at the North Star and its relationship to Merak and Dubhe, these two stars in the handle of in the bowl of the Big Dipper, and in 6 hours they are going to go 90 degrees. And then you figure out, like, so what if you wake up and they're over here, you can figure out how long you've been asleep. Is that sort of the thing that you do with them, Joni?
I have not done that, but I've tracked them before, but I've not journaled them. But I guess I never really thought beyond that about the time, being able to tell time. It's really cool.
Yeah, it's really fun. It's really fun.
The
I
other
remember
thing,
Boy
sorry.
Scout, they had us stay up all night for those who could, and we did drawings of the Big Dipper at different times, or we'd sometimes just fall asleep and then wake up a few hours later and then draw it again and then draw it again and draw it again. And it was a memorable experience.
The other thing that could be fun, what is it, the second star? I think it's in the crook of the handle. Al is a double star, a binary star, Alcor and Mizar. And those could be also mapped too, as they move and change in relation to each other.
Yep.
And I think you can see that with just binoculars too.
Well, are they a double star system? Or I thought that they were, that one of those is close to you and the other is further, but they're lined up from our position. So I don't think that they changed their position relative to each other. And so they're not a true double star, but we see them. Maybe somebody can do a quick Google search, distance to Mizar, distance to Alcor.
And I'm working off what I seem to remember from when I was a kid. So that, the information may have changed too, but.
Yeah. Oh, those are fun things to look for. And also the dimmer one, Alcor, would be, it'd be interesting to see on Avea's brightness scale, at what point does that disappear? That might be a really kind of fun one to look at, and find out at what point on the scale does that star disappear. Joni, thank you for your thoughts and ideas. I am bouncing back to my gallery. If anybody has other comments, thoughts, or ideas to share, just put up your paw. Okay. Not seeing any at this time. In a moment, I'm going to be turning off the recording. Before I do, just also want to take a moment to thank our vets out there for and our first responders for the difficult work you do. We're coming up to Veterans Day, and I think it's useful to remember to remember and appreciate what folks have done for us. I came across this the other day, and I just wanted to share it with everybody. So thank you, Robert Henry Laws, Jr., First Lieutenant, Artillery, U.S. Army. Honorable Discharge Papers, October 1960. Thank you, friends. Thank you, vets. And